Let's now write some code in order to get a better understanding of what happens in the event loop. So just like before, to get started with the coding part of the section, go ahead and grab the starter files for this section, copy them somewhere, and then open up the project in your code editor. So I have it here on the desktop and in my VS Code, and all we have here to start is this test file.txt. And so I'm going to create a new file here, and I'm going to call it the eventloop.js. All right. Now, it is actually extremely difficult to simulate the event loop properly, because we can't really put many callbacks in all the callback queues that we talked about before all at the same time, right? That situation happens when, for example, a lot of requests are coming into your app, but here locally, that's just very hard to replicate. But anyway, we will still do some very interesting experiments using some of the stuff that we learned in the last video. And what we're going to do is to write a bunch of lines of code and then try to figure out in which order they should be executed in the event loop and analyze if the results that we get actually make sense. So let's start by writing a set timeout. So basically, in order to set a timer, and I'm using an arrow function here, and the only thing that I'm going to do is to log to console some string. So console.log timer1 finished, and I want this to expire right after 0 seconds. Okay, give it a save, and then you see that it actually corrected this string here, so it changed this quotes and added the semicolon, and that's because of the prettier extension that we installed before. Now I'm not going to configure it here because for this small example that's not really necessary. Okay, so that is setting a timer. Then let's also use set immediate. So remember that from the last video. Okay, now I'm not going to explain a lot here. For now, let's write this code and then analyze what happens. Okay, so set immediate, and just like the other timer, it receives a callback function. And all we're going to do is to write the immediate one finished. And this one doesn't have any time because that's not necessary because, as the name says, it is immediate. Then another thing that we want to do is to read this file here and then pass a callback function. Okay, so the first thing is that we have to require the correct module. So fs, and now fs.read file, and we want test file.txt, and then something to happen. And just like before, let's just say here, in this case, IO finished. All right. So IO, because this callback here is actually related to a IO task, which actually gets its own phase in the event loop, right? And then finally, let's just add a console.log here saying, well, hello from the top level code. Okay, so top level code, because it's actually the only one that is not inside of any callback. So in this very small example that we have for now, let's try to figure out what should happen first. Well, remember that the first step when we load a module is that its top level code gets executed. So right away, we should see this console.log here, right? Only then later, we should see the other logs coming from these other callbacks, because these callbacks will actually run in the event loop. So let's try to see if that's actually the case and then analyze it a bit better even. So opening up the console here, and again, I'm doing that by using terminal, or actually in the view. So this terminal here, all right? So node eventloop.js, or actually before we do so, I need to fix this typo here. So it's test file, not text file. Okay, but now we're ready to run this command. And the results are in. So the first log that we have here is hello from the top level code. And that was expected, right? Because this is a code that gets executed immediately. Then after that, we have these 3 outputs, but they are actually in no particular order. And that's because this code here, so this code is actually not in an I/O cycle. So it's not running inside of the event loop because it's not running inside of any callback function. Okay, so on your computer, you might actually see this log here before this one. And then this one here is only the last one because this kind of big file here takes some time to read. And so it's probably always going to be the last one. So again, at this point, the order of these three here doesn't have anything to do with the event loop because they're actually not running inside the event loop just yet. For that, we will have to move them, or at least move these two here, inside a callback function. And so for that, we're going to use this one here actually. So let me put it here and say timer 2 and timer 2 here, or immediate 2. And I'm also going to add another timer here. So timer 3, and this one is going to run for 3 seconds. So that is 3000 milliseconds. So let's now try the result of this one. But before we do that, let's actually think why right after all the code before had run, the program then exited and went back to the prompt here. So remember how Node.js decides if it should continue running the event loop? Well, it does so by asking if there is still any timer running in the background. And if so, it will not finish. And if there is still a pending timer, well, then it's not gonna exit the program. But if there's not, which was the case in the first example here, then it immediately exits the program. Okay? But now we actually have one timer here. So this one will run for 3 seconds. And so let's try to figure out what happens here. Okay, so you see that it's not exiting, and only now after timer 3 has finished, it did then exit the application. Okay, so let's actually just see that again. So all these logs, timer's running, timer finished, and so it exited the application. Now about these results here, let's actually make this here a bit easier to see and add just a small separator here. Okay, clean this. Okay. So these 4 ones here are the outputs that were not really running in the event loop, but these 3 here were actually coming out of the event loop. So let's now analyze these results. Now, if you remember the diagram from the previous lecture, you will probably have thought that the timer, so timer 2 here, should actually finish before the set immediate, because in the diagram it actually appeared first right at the top of the event loop. So we have this set timeout here with 0, which should kind of be the same as set immediate, right? So why does set immediate actually appear before the set timeout? Well, there's something that I didn't really explain in the last video because I didn't want to make it even more confusing. And that is that the event loop actually waits for stuff to happen in the poll phase. So in that phase where I/O callbacks are handled. So when this queue of callbacks is empty, which is the case in our fictional example here, so we have no I/O callbacks, all we have is these timers, well, then the event loop will wait in this phase until there is an expired timer. But if we scheduled a callback using setImmediate, then that callback will actually be executed right away after the polling phase and even before expired timers, if there is one. And in this case, the timer expires right away, so after 0 seconds, but again, the event loop actually waits, so it pauses in the polling phase. And so that setImmediate callback is actually executed first. So that is the whole reason why we have this immediate here after we have the timers. Okay? And I know this sounds very confusing, and I completely agree, but really that's just the way Node.js works. And now let's make this even a little bit more confusing and add the process.nextTick that we talked about also in the last lecture. So we say process.nextTick, and then just like before, we simply pass it a callback function. And again, I just want to log to the console, and I'm going to say process.nextTick. So what do you think will happen in this case? Go ahead and make a guess, and once you're ready, you can then run this. So let's do that. Save it here first, run it, and so here we go. So the results are again in, and now the first callback that was executed was actually this function here. So that's why we have process.nextTick right in the first one. So why was this callback function of process.nextTick the first one of all of them to be executed? Well, remember that nextTick is part of the microtasks queue, which get executed after each phase, so not just after one entire tick. And so what happened here is that this callback function actually ran before the phase where this callback function here ran and the phase before that. Okay? Now, nextTick is actually really a misleading name because a tick is actually an entire loop. But nextTick actually happens before the next loop phase and not the entire tick. So that's what I was saying before. Then on the other side, setImmediate would make you think that its callback would be like executed immediately, but it actually doesn't, right? So setImmediate actually gets executed once per tick, while nextTick gets executed immediately. And so their two names should actually be switched. They should be the other way around. And this can cause a lot of confusion, so it's best to just always stick to one of them. And that's usually setImmediate and not process.nextTick. Now, anyway, as I mentioned in the last video, these mechanisms are actually more for pretty advanced use cases, which is why we will probably not use them in our project. But if you want to learn more about them, you can always read the official node documentation. Okay? So with this, we have simulated some aspects of the event loop, but to finish, I want to just quickly introduce something about the thread pool as well. And for that, we're going to do a more complex operation that will actually be offloaded to the thread pool and take a look at how long these operations take to run and how we can change the thread pool size that we talked about before. So we're going to use some cryptography here to basically encrypt a password. So that's a new package we hadn't used before, and it's called crypto. But I mentioned earlier that actually all the functions from this package, they will be offloaded automatically by the event loop to the thread pool. And so that's what we're going to test out now. And let's use this now. So crypto.pb, so we're going to use an encryption function called pbkdf2. So kind of a weird name. And now we pass in the secret string, which let's just say password. Then we need a string to solve the password. And the implementations here don't really matter. So for now, I'm not going to go into any detail of how this works. We're going to do that later. Okay, so here we just need the key length. So this number here is just for the number of iterations. Then this is the key length. And then finally the algorithm, which is going to be used to encrypt the password. So these numbers will simply increase the time it takes for the encryption. Okay, and then finally, it also takes a callback function. And all I'm going to do here is to do another console.log and just say password encrypted. Now, for the purpose of this demonstration, I actually want to show you how much time each of these operations take. So what we're going to do is to basically define a variable in the beginning, set it to date.now. So that is the current date in milliseconds. And then here, all we have to do is to log not only the string, but also date.now, which will be the date at this point in milliseconds minus the start. And so that will then give us the amount of milliseconds that have passed in order to do this calculation. Okay, so let's try it out, give it a save, and run it again. And so here you see that it took 1855 milliseconds, so almost 2 seconds to encrypt this password. Okay, but now let's actually duplicate this code, or actually I want 4 instances of this to show you something. So if we run this now, it should probably take approximately the same amount of time. And yeah, it does. So it was 1.8 seconds, now it's 2.2 seconds, which is quite similar. Okay? And remember that I told you in one of the earlier lectures that by default, the size of the thread pool is 4. So there are 4 threads doing the work at the same time. And so that's why these 4 password encryptions take approximately the same time and happen basically all at the same time. But we can actually change that thread pool size. So let me show you how we do that. And we do that by saying process.env, and that's an environmental variable. And again, we're going to talk more about that later. And uv, which stands for libuv, thread pool size. So if we set this to 1, we will only have one thread in our thread pool. So let's try that again. And so let's see what happens now. So you see that they all take much longer to calculate. Basically, they are calculated one after the other. So this one the first, then this one here takes double the time. And again, that's because this one can only start as soon as the first one is completed. And the same with the third and the fourth one. Now let's say we change it to 2. Then we should see the first two ones with the same time, and exactly the second two also at a similar time. So that makes sense, right? Just for the sake of completion here. Now the same thing with 3. So these 3 have a similar time, and then the last one. All right. So this is how the thread pool works, basically. So I decided to not only focus on the event loop, but also to give you an overview, a very quick one, of the thread pool and how we can change the thread pool size. Okay? Keep in mind that this code here is actually still asynchronous because we pass in a callback function. Okay? And we could actually use the synchronous version, but that would then block the event loop. Want to see that? So let me very quickly show that to you as well. So that one was not really planned, but let's do it anyway, because it's very interesting to see that, I think. Okay, so that would work like this. We use, again, the sync version of the same function, which in Node is many times available. Remember, we have the same for the read file. So we have read file, which accepts a callback, and we have read file sync, which is the synchronous version, which doesn't accept any callback. So just like this. So this one will then encrypt the password, block the code execution, and then move on to the next line, which will then log this here to the console. So let's now duplicate this here. Oh, that was too much. Get rid of this one here. And so now these 4 password encryptions will no longer run in the event loop. And so they will no longer be offloaded to the thread pool. Okay? And so now, even if we have the thread pool size of 4, let's see what happens. So you see, they happen completely in a synchronous way. So one after the other. And what is even worse is that all of these timers here, even next tick and the immediate one, only appeared after the password encryptions happened. So this really was blocking the entire execution. Even if this timer here, for example this one here, was finished after 0 seconds, and this one after 3 seconds, but they all had to wait 7 seconds until all of these password encryptions here were finally ready. Again, because they were not running inside the event loop, but these were. And so they were basically working in the background and could only be picked up by the events loop when they were ready, right after these 4 password encryptions. So this one was another great example of seeing the code blocking and event loop all in action. Okay, so that was enough for one lecture. I hope that you found it interesting, and I'll see you right in the next one.